Hello students. Today we're going to look at solving systems of equations by substitution. Now, in the last video we watched, we solved systems of equations by graphing them, and when we graphed them, they formed two great lines, and we could see where they crossed, and the point where they crossed was the solution. Well, sometimes the graphs don't turn out so pretty, and sometimes it's more difficult to graph them and find the answer, the solution. So there are three other ways that I told you we would learn them, and the next one is substitution. What we're going to do in substitution is we're going to solve one of the equations for one of the variables. For instance, this top equation is already solved for one of the variables, y equals 2x plus 1. Y is by itself, and so that's good for us. Because when we're going to do substitution, we have to have one variable that is by itself. Doesn't matter which one, as long as one variable is by itself. So here's my system of equations, y equals 2x plus 1 and 3x plus y equals negative 9. And we're looking for the solution, which is one point that will satisfy both systems. Okay, so here's what we do. We take y equals 2x plus 1. I know that y is 2x plus 1, so instead of using this y right here, I'm going to use 2x plus 1 because it says y equals 2x plus 1. So instead of using y, I'm going to use 2x plus 1. So I would rewrite this equation as 3x plus 2x plus 1 equals negative 9. So I just use what it told me. It told me y equals 2x plus 1. So instead of that y, I can just plug in 2x plus 1. Now all I have is x's. And that's the next important part because now I'm going to solve for x. So 3x plus 2x is 5x plus 1 equals negative 9. Now I'm going to move the 1 to the other side by subtracting 1 from both sides. So 5x equals negative 10. That means x equals negative 2. So now I know that x equals negative 2. So I'm going to take that x equals negative 2 and I'm going to plug it back into this original equation. I know what the x value is. Now I've got to find the y. So if I plug in negative 2 into this equation, it's going to tell me what y is. Well, 2 times negative 2 is negative 4, and negative 4 plus 1 is negative 3, so y has to equal negative 3. So the solution to this system of equations is negative 2 comma negative 3. Well, let's try it just in case. Oh, I need to fix this real quick. There we go. So let's plug it in. 2 times negative 2 is negative 4 plus 1 is negative 3. We got that one. Well, it's this one. 3 times negative 2 is negative 6. Negative 6 plus negative 3 is negative 9. So this point works for both equations. So there's my solution. So let's look at another example that doesn't have an equation that's solved for one variable yet. So I have x plus 2y equals 6 and 3x minus 4y equals 28. That's my system. Now I'm still going to use substitution, so I need to see, is there one of those variables that is by itself or has a coefficient of 1? Well, x has a coefficient of 1, so why don't I just solve this top equation for x? So in doing that, I have to subtract 2y from both sides. So x equals 6 minus 2y. You could also do negative 2y plus 6. In this case, it doesn't matter because I'm not graphing it. So now I know x equals 6 minus 2y. So let's plug x here. Let's substitute 6 minus 2y for this x. That's where the whole word substitution comes from. I'm substituting this x for 6 minus 2y. So 3 times the quantity of 6 minus 2y, because that's what x equals, minus 4y equals 28. The only thing I changed is the x. Everything else is still the same. Now we need to do distributive property. 3 times 6 is 18. 3 times negative 2y is negative 6y. Minus 4y equals 28. Combine like terms. Negative 6y minus 4y. This is where you've got to be really careful and make sure you add and subtract properly, which is where your calculator could come in if you needed to. Negative 6y minus 4y is negative 10y. So I've got 18 minus 10y equals 28. Well, I'm trying to get y by itself, so I got to get rid of the 18 first. So I'm going to subtract 18 from both sides. And I get negative 10y equals 10. So we know that y equals negative 1. I wrote it on the side because the camera space. Well, that didn't help anything either, so I'll just move the camera. So we know now that my y is negative 1. So if my y is negative 1, I can go back to one of these equations and plug in the y. Well, I'm going to deal with the first one because it's easier to deal with. So I'm going to plug in negative 1 for the y. So let's see if I have room over here to do this. So I have x plus 2 times negative 1 equals 6. I just took that negative 1 and stuck it where the y is. And so then I have x minus 2 equals 6, because positive 2 times negative 1 is negative 2. So x equals 8, because I added 2 to both sides. So x is 8 and y is negative 1. So the solution to my equation, or my system, is 8 comma negative 1. Let's plug them in and see to the original equation. 8 plus 2 times negative 1 is negative 2. 8 plus negative 2 is 6. That one works. Now 3 times 8 is 24. Negative 4 times negative 1 is positive 4. So 24 plus 4 is 28. So that, in fact, is my solution. 8 comma negative 1. So here's my next system of equations. Y equals 2x minus 4, and negative 6x plus 3y equals negative 12. Well, the good news is I already have one variable solved by itself on its own, so I can just use that. I know that y equals 2x minus 4, so instead of y here, I'm going to put 2x minus 4. So we have negative 6x plus 3 times the quantity of 2x minus 4 equals negative 12. Got my parentheses. Okay? All I did is take this y and change it to 2x minus 4. Have to put it in parentheses because I've got the 3 on the other side. So now, let's keep going. Negative 6x plus 6x minus 12 equals negative 12. Combine like terms. Negative 6x plus x is 0. So those cancel out. And all I'm left with is negative 12 equals 12. And you think, whoa, there's no variable anymore. You're right. So here's where we have to ask ourselves this question. Does negative 12 equal negative 12? Absolutely. This is what we call an identity statement. The identity on the left is the same as the identity on the right, so that makes it an identity statement. It's true. Now, when you get an identity statement that says one number is equal to another number and no variables are involved, we have an infinite number of solutions. The reason is these two equations are exactly the same line. And when those two equations are exactly the same line, we call them coincident. And that means that there's an infinite number of solutions to that system of equations. Once again, if I have my variables eliminated, and I have a true statement, negative 12 equals negative 12, then I have an infinite number of solutions. Well, since you can have a true statement, you can have a false statement. What if I came up with negative 6 equals 0? In another problem, in another situation. If I came up with a statement, I got rid of my variables, they eliminated themselves, I came up with negative 6 equals 0, that's a false statement. And anytime we get a false statement, then the answer is no solution. Okay? True statement or identity, infinite number of solutions. False statement, no solution. Those are key because you will come across those sometimes where these two have no solution because they're parallel. And we don't need to worry about finding the slope and all that kind of stuff. We can just figure out when we get that statement at the end. Once again, this is only when the variables are eliminated. If we still have variables, then we have to keep going. And here are your two practice problems for this video. Solve these systems of equations using substitution. The first problem is y equals x plus 5 and 3x plus y equals 25. Okay, that's your first system. Your second system, y equals 3x plus 4, and negative 6x minus 2y equals negative 8. You already have y solved for itself. So you just have to substitute what y equals in for y in each equation. Okay? Two separate problems. Do them separately. Take a picture. Submit it through Edmodo, or if that's a problem, email it to me. But make sure you have it done before class starts.